In this video, we're going over the concepts for Chapter 9, which is titled Alcohols, Ethers, and Amines. We are first going to talk about the functional group of alcohols. In the previous chapter, we learned that alcohols are classified by having specifically a carbon chain, which in this case is represented by an R group, and R just means rest of molecule. So whenever we have a hydrocarbon chain, so any length of carbons, including their hydrogens, and when that is covalently bound to an OH group, that is known as an alcohol. Alcohols can be aromatic. So as you can see, if we have a benzene ring connected to OH, that is known as a phenol, and that's an example of an alcohol. In this case, since we have a covalent bond to OH, that is known as a hydroxy group. Back when we were doing general chemistry, we saw the hydroxide ion. So let me just write it down. So hydroxide represents when OH has a -1 charge, and it is an ion. And we saw that more recently in the context of bases. But remember that if you have hydroxide, that is an ion, and many times we see it involved specifically in ionic bonds. So whenever we have a covalent bond to OH, that is known specifically as a hydroxy group. Let's understand that alcohols can be found in many food items, including alcoholic beverages, including beer, as you can see in figure 9.2. Let's now discuss how we name alcohols. The steps are actually outlined in the left side of the slide, but I'm just going to directly go into how do we do it, and I'm going to name the molecules that we have on the right side. So you can go ahead and read the steps that you have on the left side, but I'm going to directly doing the steps on the molecules that we have on the right. So when we have an alcohol, similar to what we have done so far in the semester, we must find the longest continuous chain of carbon atoms. That longest continuous chain of carbon atoms needs to include the carbon that is holding the OH. So in the following molecule, we could select the longest chain as being this chain or this chain. Now, it doesn't matter which one of the two that I highlighted you select, it will end up with the same number. So let me just go ahead and do the one that is going left to right. Now, when we are numbering that longest continuous chain of carbon atoms, we have to start numbering it from the end that is closest to the carbon that is holding the OH. So in the case of this molecule, is going to be carbon number 1, carbon number 2, number 3, number 4, number 5, and number 6. And we must number it from right to left because that end is closest to the carbon that is holding the OH. Similar to what we have done before, we have to name that longest continuous chain of carbon atoms. And remember that when it comes to the pattern for naming, we're still following the idea of having, let me change the color of this. We have to have a prefix, a root, and an ending. Now, when it comes to the root, Since we are naming an alcohol, we must write specifically the alkane name for the longest carbon chain. So understand that if we have 6 carbons in a row, you're going to write the name as hexane. Now, this root name, we have to replace only the last letter, which means that we're going to take away the E, and that E is now going to replace by the correct ending. If we have an alcohol, that means that the name is going to end in OL. So when it comes to naming, the ending is OL. The root is going to be, quote unquote, the alkane name without the E at the end. Now, in alcohols, we need to give location to where is the OH present, which means that for this molecule, at carbon number 2 is where I have the OH. So let me include that before the root, we need location of carbon with OH group. The prefix specifically, just like before, is going to be the location and name for any substituent that we have. So let me just write it right here. This is going to be location and name of the substituent, which means that for this molecule, it's going to be on carbon number 5, we have a methyl group. And you can see that we still need hyphens every time we are dividing numbers and words. So the correct name for this alcohol is 5-methyl 2-hexanol. Let's do another example. In the following example, let's find the longest continuous chain of carbon atoms. In this case, it's going to be this carbon, this carbon, this, and this. So the longest continuous chain of carbon atoms, starting from the end that is closest to the OH, is 4 carbons. And we will number them 1, 2, 3, 4. As we have seen before, we have to write for the root the alkane name for 4 carbons. So that means that I'm going to write butane. Because this is an alcohol, I'm going to delete the E and replace it by OL. Then we're going to give the location for the OH, which means that at carbon number 2 is where we have our hydroxide. Then, as a prefix of that, we're going to put the substituent that we have here, which means that at carbon number 4, I have a bromo group. And the name of this molecule is 4-bromo-2-butanol. Alcohols can be cyclic. And whenever we have a cyclic alcohol, the rules are similar to what we have seen in the other 2 examples. We can observe that our longest carbon chain is going to be the cyclic system because that's where the OH group is. So when it comes to this, that ring system, since it has 5 carbons, 1, 2, 3, 4, 5 carbons, Or more correctly, I should start at the carbon with the OH because that's where everything originates. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. The root name for this is cyclopentane. And we are going to replace the E in the cyclopentane with OL because this is a cyclic alcohol. Now, when we have a cyclic alcohol, we're going to start numbering the ring system only, starting from the carbon that is holding the OH. So to number this molecule, I will do this as carbon 1. Then I have to make sure that the substituents, if there's any present, around the ring system will have the lowest possible number. So this is carbon number 1. And in this case, I have to go counterclockwise. In other cases, you may go clockwise, but in this one, it's counterclockwise. So this is carbon 1, this is carbon 2, this is carbon 3, carbon 4, and carbon 5. Now, in cyclic alcohols, different from the straight chain alcohols, I don't need to put the position of the carbon that is holding the OH because carbon number 1 in the ring system will always be the one that is holding the OH. The only thing that I have to do here is just write the substituent, and in this case is going to be a propyl group because if you observe, we have 1 carbon, 2 carbons, 3 carbons. If I convert this skeletal structure to condense, then this is a CH2, this is a CH2, followed by a CH3. So this is a propyl group. And this propyl group is coming off carbon number 2 in the ring system. So in the cyclopentanol, which is our root and our ending, I'm going to write that at position 2. It has a propyl group. So the correct name for this compound is 2-propyl cyclopentanol. Let's now go over how to name molecules that contain the alcohol called phenol. I'm going to discuss the naming that we observe in the molecules below. Whenever a benzene ring connects to an OH, that is known as a phenol group. It doesn't matter the position of the OH group. It could be at any of the 6 carbons that are present in a benzene ring. As long as we observe that one of those carbons has an OH group, the whole thing is called a phenol. Typically, we see many drawings in which the phenol group is written on this carbon, but understand that it could be present anywhere in the ring. When we are naming things that have phenol in them, let's understand that specifically the parent chain is always going to be the phenol group. That's why we see the word phenol at the end of the compound. Next, similar to what we observed when it comes to the cyclic alcohols, carbon number 1 is going to be the carbon in the ring system that is holding the OH. Next, we are going to define the numbering system within the ring, which means that we can go clockwise or counterclockwise to give the substituents in the ring the lowest possible number. In this example, it doesn't matter if we go clockwise or counterclockwise, meaning that if I count it clockwise, this is carbon number 1, 2, 3, 4. But if I counterclockwise, this is carbon 1, 2, 3, 4. This bromine is always on carbon 4. So in this example precisely, it doesn't matter, but you always have to find in any ring system, as long as you put carbon number 1 that is holding the OH and a phenol or a cyclic alcohol, then you have to give the substituents that are around the ring system the lowest possible number. In this case, I chose to number the carbons in the benzene ring clockwise, but you could have done it counterclockwise. At the end of the day, we see that at position 4, we have a bromine. That's why the prefix is location, name of the substituent, which is 4-bromo. And the correct name for this compound is 4-bromophenol. Let's look at another example of phenol. The parent chain is going to be the phenol group. And in this case, similarly, we are going to number the carbons in the ring system. This is carbon 1, and we can go 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. This is another example in which it doesn't matter if we number it clockwise or counterclockwise. So it depends on the molecule given. In this case, I'm going to number it counterclockwise. Carbon 2, 3, 4, 5, 6. And we see the substituents specifically on carbon 2, on carbon 4, and on carbon 6. This is their location. And since they're all the same, tri represents that there's 3 of the same. Bromo tells you that they're all bromines. Remember that when you're numbering a ring system, it could be a phenol or it could be a cyclic alcohol. The main thing to remember is that once you number carbon number 1 as the carbon that is holding the OH, then you could do clockwise or counterclockwise, but the decision of which one, in which direction you're going to number will depend on given specifically the substituents in the ring, the lowest possible number. Additionally, alcohols can be classified depending on the carbon chains that are attached to the carbon that is holding the OH. When we are classifying alcohols, alcohols can be classified as we can see, a primary alcohol. And a primary alcohol means that the carbon that is holding the OH is attached to one carbon chain. Alcohols can be classified as secondary alcohols because the carbon that is holding the OH is bonded to 2 carbon chain. Lastly, alcohols can be classified as tertiary alcohols. And a tertiary alcohol is going to be a carbon atom that is holding the OH is connected to 1, 2, 3 carbon chains. Let's do some examples of how we determine the classification for certain alcohols. If you're giving skeletal structures as we see below, the first step will be that you convert it from skeletal to condensed. So if I look at this molecule, and this is cyclohexanol, I can observe that in cyclohexanol, this is a CH, this is a CH2, this is a CH2, 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 CH2. The carbon that is holding the OH is connected to, let me fix this. This is a CH2. The carbon that is holding the OH is connected specifically to 1 carbon chain, 2 carbon chains. So cyclohexanol is going to be a secondary alcohol. If we look at this molecule, and I'm naming them just for practice, This molecule specifically, let me just write in the carbons and hydrogens. This is a CH2. This is a CH. This is a CH3. This is a CH. This is a CH2. This is a CH3. This molecule specifically will be if this is 1, 2, 3, 4, 5. This is 3-bromo, 2-methyl, 1-pentanol. And when I look more closely at the carbon that is holding the OH, I can observe that there's only one carbon chain attached to it. So that's why this is a primary alcohol. This cyclic alcohol, this is carbon 1, 2, 3, 4, 5, and 6. The name of this molecule is 3, 5 dichlorocyclohexanol. And I can see that in this molecule, let me write in the carbons and hydrogens. This is a CH, CH2, CH, CH2, CH, CH2. I can observe that the carbon that is holding the OH is connected to one carbon chain, two carbon chains. So this cyclic alcohol is an example of a secondary alcohol. And in the last example, let me write in the carbons and hydrogens. This is a carbon. This is a CH3. This is a CH3. This is a CH2. This is a CH2. And this is a CH3. The name for this alcohol specifically is going to be 2-methyl, 2-pentanol, and when it comes to its classification, since the carbon atom that is holding the OH is connected to 1, 2, 3 carbon chains, 2-methyl, 2-pentanol, it's an example of a tertiary alcohol.